In this session, let us see what is meant by oil circuit breaker, which are the various types of oil circuit breakers available, its construction, its properties, its advantages and disadvantages. So, mineral oil has a very good insulating property when compared to air. Okay, that is why we use the oil as a medium to quench the arc in the case of a circuit breaker. So this oil has also a very good cooling effect. So only a disadvantage of using the oil in circuit breaker is it is inflammable, and that is it might cause a fire hazard. And the other disadvantage is if this oil gets into contact with any other medium, it can form an explosive material. And when we use oil and when the arc is formed between the contacts of the circuit breaker, there is the carbon particles which is formed when the oil is getting heated up. So which in turn will reduce the dielectric strength of the oil. So what will happen? You need to refill the oil then and then. So maintenance is more in the case of oil circuit breakers. So that is the main disadvantage in the case of oil circuit breaker. In spite of all this disadvantage, so you have a few of the oil circuit breakers which is used for low current interruption, but this oil circuit breakers is not suitable for very heavy current interruption, mainly due to carbonization of the oil. So which are the different types of oil circuit breakers available? So the first one is a plain break oil circuit breaker. Second one is a self-generated pressure oil circuit breaker. The self-generated pressure oil circuit breaker are further three types based on the construction, that is plain explosion pot, cross-jet explosion pot, self-compensated explosion pot. And the next type of oil circuit breaker available is double break type oil circuit breaker, and the last one is bulk oil and minimum oil circuit breakers. So now let us see each one of these oil circuit breakers in detail. The first one is plain break oil circuit breakers. So all the oil circuit breakers will be having a tank, okay, so that the oil is filled in the tank. So you have a metal tank here which you can observe. This is the metal tank. So you have three openings here at the top, okay, and nothing but the vents, and the oil is filled in this tank. And you can observe that the contacts are placed within the oil, okay, within the tank where oil is present. So this is the transformer oil which is there. You have the contacts, fixed contacts on the top, okay. It is a double type, double break type, okay, double break type. So you have one contact, that is the top one is your fixed contact and the bottom one is the moving contact, okay. Now that is two breaks you will have. This is the first break and this is the second break. The tank which is present, it should be very strong, okay, and it should be earthed. The tank should be earthed. So now when there is a fault, the contacts get separated. When the contact gets separated, obviously you know that an arc is formed across the contacts. So this arc will decompose the oil which is present around the contacts into gases. So the oil decomposes into gases. The gas which is obtained from the oil is mainly nothing but hydrogen. So the volume of the gas which is produced will be around 1000 times that of the oil which is decomposed. So once the gas is formed, it pushes away the arc. So the oil will be pushed away from the arc and the gaseous medium will be surrounding the arc. So that gaseous medium which is surrounding the arc, okay, it will make the arc to quench. So how? So a large gaseous pressure will be developed because of a large amount of energy which is dissipated within the tank, and the tank should be designed in such a way that it can withstand that large pressure. So I told you, when the gas is formed around the arc, the oil whatever is present around the contacts will get displaced. So what will happen to the oil? There will be a large pressure, the oil will be pushed away at a very faster rate. You should see to that the oil will not go out of the tank. Okay. So to accommodate the displaced oil, you see you have an air cushion which is provided. Okay, that means you shouldn't fill the tank full with oil. You should provide a space, that is the air cushion has to be provided, so that whenever the arc is formed, the oil when it gets displaced, it should have a sufficient space enough. Okay, so that air cushion, what it does is it will absorb the mechanical shock which is produced due to the upward movement of the oil. And you can see you have a vent which is provided here. Okay, that vent is nothing but the gas outlet. So you should see to that the pressure is maintained within the prescribed level within the tank, so that it never gets damaged. So the arc quenching factors will be by lengthening of the arc, that is nothing but the elongation of the arc. So the formation of the gaseous medium, it will produce a high dielectric strength, and the oil movement also will try to quench the arc. So this particular plain brake circuit breakers, they are used for low current interruption at comparatively lower voltages. So they are used on low voltage DC circuits and low voltage AC distribution circuits. So they require a large amount of transformer oil and the speed is slow. So they can be used up to 11 kV for interruption, okay, with the capacity of around 250 MVA. This is the plain brake oil circuit breaker. Next is self-generated pressure oil circuit breaker. So the self-generated pressure oil circuit breaker are mainly of three types, that is plain explosion pot, cross-jet explosion pot and self-compensated explosion pot. So all these three types of self-generated pressure oil circuit breaker, as the name indicates, the arc energy itself, it is utilized to generate a high pressure. That is why it is called as self-generated pressure. So the arc which is formed across the contacts, it itself generates a high pressure in the chamber. Okay, not the displacement of the oil. So the arc energy will generate a high pressure in a closed chamber. That closed chamber is called as the explosion pot, or you call it as a pressure chamber, or you call it as a arc controlling device. The contacts will be placed within the pot. So as you can observe here, this is the enclosed pot, okay, closed pot it is, and the contacts will be present. The contacts will be present within the pot. So here actually the moving contacts have started to separate. So actually these two contacts of the circuit breaker will be placed within the pot. So the pot is made of insulating material, and that pot is placed inside the tank. Okay, this pot is placed inside the tank. So this particular type of circuit breakers will have a very high interrupting capacity. Okay, and since the pressure is developed by the arc, the arc pressure, it depends on the magnitude of the current. So if the current is low magnitude, then the pressure will be low. If the current is of a high magnitude, then the pressure will be high. So this will lead to a problem in designing a suitable explosion pot. So at low current, the pressure generated is should be sufficient enough to quench the arc. The pressure will be low, then also the pressure generated should be sufficient enough to quench the arc. So at very high current, high pressure will be developed. You should see to that high pressure will not burst the pot. So this is one disadvantage in the self-generated pressure oil circuit breaker. So let us see the first one, that is the plain explosion pot. So as you can see, this design is very simple. Okay, you have a pot which is placed inside the tank. So inside the tank you have oil, right? So now the contacts are placed within the pot. So now when the fault occurs, the contacts get separated, the arc will be formed here. Okay, the arc is formed between the contacts, that is the fixed contact and the moving contact. The oil which is present will be decomposed and the gas will be produced. So it will generate a very high pressure within the pot because you have a very narrow opening here. Okay, it will generate a very high pressure because the nozzle or the opening which is there, which is very narrow, that too at the lower end of the pot. This is present at the lower end of the pot. So this high pressure which is developed will cause a stream of gas to flow axially. So the gas will flow axially along the arc, which will actually sweep away all the ionized particles. Okay, so actually the arc has to quench. If the arc doesn't quenches within the pot, then once the moving contacts moves out of the pot, the arc will quench. So this type of spot is not suitable for very heavy currents. That is because I have already told you, if the current is high, the pressure developed is very high, then there will be a chance that the pot gets busted out. So this type of oil circuit breakers is used to interrupt a low magnitude of the currents. So when the magnitude of the current is low, the pressure is low. If the pressure is low, it will take more time to quench the arc. Okay, so you use it only for low currents. Next, coming to the cross-jet explosion pot. So as the name tells, here the arc is quenched cross and it is not axially. Okay, it is perpendicular. So you have arc splitters. Can you observe here? It is arc splitters. This is a pot. Okay, the fixed contact and the moving contacts are there. Obviously, again I will not repeat the same thing. On the occurrence of the fault, you have an arc formed. So the moving contacts get separated. When it gets separated, you have arc splitters, is it not? So that will split the arc. Once the arc is splitted, nothing but the arc is quenched. So the arc splitters are used to increase the length of the arc, okay, when the moving contacts are traveling. So in this type of pot, the oil blast is across the arc and hence it is known as a cross-jet explosion pot. This particular cross-jet explosion pot is suitable for high current interruption as compared to your plain explosion pot. So next is self-compensated explosion pot. The self-compensated explosion pot is a combination of plain explosion pot and a cross-jet explosion pot. So its upper portion is a cross explosion. Okay, this is the upper portion. Upper portion is a cross-jet pot and the lower one is a plain explosion pot. So if when the moving contacts get separated, if the arc doesn't get splitted by the arc splitters over here, it will quench when it has crossed the lower contact. So if the arc doesn't quench at this point, then it quenches at the point that is at the where you have a design of the plain explosion pot. So initially, when the current is low, the pressure is very less. So most of the times the arc doesn't get split at this point. So once the pressure gets builded up and the moving contacts is still moving, the arc is quenched at this point once it moves out of the pot. So this particular type of self-compensated explosion pot is suitable for low as well as high current interruption, because plain explosion pot you use it for low current interruption, whereas high current interruption is taken place by cross-jet explosion. So both self-compensated and the self-compensated explosion pot has both a cross-jet and plain explosion pot. So it can be used for both low current as well as high current interruption. Next is double break oil circuit breakers. As the name tells, you have two breaks here. That means to say two arcs are formed. So you need to have three contacts. So you have a third contact which is called as an intermediate contact here. So you have fixed contact, moving contact and the intermediate contact. So initially all these contacts will be closed. So once the arc is formed, the moving contact along with the intermediate contacts starts to move downwards. Initially the arc will be formed only between the fixed and the intermediate contact. That is because the moving contacts and the intermediate contacts will be held together. So once the intermediate contact stops, the moving contact is still moving, then the second arc will be formed across the intermediate contact and the moving contact. So the main aim here is to quench the second arc quickly, that is by using the gas pressure and the oil momentum which is due to the first arc. This is especially required to interrupt the current which is below the rated maximum current. So this is the double break oil circuit breaker. Next, the last, this is the another one. This is a cross blast double break oil circuit breaker. And the last one is bulk oil and minimum oil circuit breaker. As the name indicates, bulk oil circuit breaker, large quantity of oil is being used. Okay, so this type of circuit breaker is also known as a dead tank type circuit breaker, and the tank is held at earth potential. It is held at the earth potential. So what quantity of oil you are going to use, it depends upon the system voltage. So if the output rating of the voltage is 110 kV, say for example, then it requires around 10,000 kg of oil. And if the output rating is around 220 kV, then it needs 50,000 kgs of oil in the case of bulk oil circuit breaker. So this bulk oil circuit breaker, the oil which is used, it performs two functions. One is it quenches the arc. Second one is it acts as an insulator. It insulates the live part of the circuit breaker from the earth. So the quantity of oil which is required for arc quenching is only about 1/10 of the total oil which is being used. Okay, 1/10 of the oil which is present in the tank, only that much is required for arc quenching, and all other remaining oil which is present, no, it is required only for insulation. So when you have large quantity of oil, so whenever the arc is being quenched, large amount of oil, the carbon particles are being generated. So what will happen if large amount of carbon particles are generated due to heating of the oil? The insulating property of the oil will get reduced. So you need regular maintenance, and you see when large quantity of oil is required, replacing it then and then, it is a huge cost as well as maintenance is more. That is why instead of going for bulk oil circuit breaker, we can go for minimum oil circuit breaker, wherein a lesser quantity of oil is required as compared to bulk oil circuit breaker. And the same thing, this type of bulk minimum oil circuit breaker, it is insulated from the earth, and you have a closed arc chamber also. Okay, you have the outer part is made of porcelain. The advantage of this minimum oil circuit breaker is, first thing is, it requires lesser quantity of oil. The space required is also very small. It is lighter in weight compared to the bulk oil. It is having a reduced risk of fire and a less maintenance work when compared to the bulk oil circuit breakers. So the disadvantage anyways is, once it is oil, you have carbon particles. The formation of carbon particles will be very more, and you need to remove the gas. That means you have to provide a vent, suitable vent, so that the gas is moved out of the chamber. That is the disadvantage. So this is how a minimum oil circuit breaker looks like. Uh, this is a closed chamber. The contacts are present in the chamber. You have a supporting chamber over down. This is the upper chamber, this is the lower chamber. You have a supporting chamber wherein you have a oil which is present. So this oil is used for both insulation as well as for an arc quenching medium. This is the top chamber. You have a gas vent at the top provided for the gas to escape, and there is a drain valve wherein the oil is being removed and you have to replace the oil. And the moving contact tube is actually fixed, is a fixed piston. So when the moving contacts moves downwards, it forces the insulating oil. So when the moving contact gets down, the oil enters into the chamber and it quenches the arc, or it removes all the ionized particles. So that is how the arc gets quenched. So this is the minimum oil circuit breakers. So you have seen various types of oil circuit breakers which are available. So the plain explosion pot kind is used to interrupt low magnitudes of current. The self-generated pressure oil circuit breaker is used for interruption of it is low current as well as a high current interruption. So again, you have a double break type oil circuit breaker which can be used to interrupt low magnitudes of current, which is lower than the rated maximum value. Next, you have the bulk oil and minimum oil circuit breaker.